All right, so this is starting 2D arrays. So 2D arrays is like a matrix or a table. So a 2D array, so a matrix, which is what we've talked about in math over and over again, and some people like to call it a table. And remember, just like before, everything's always going to start at 0. There are two ways we can instantiate it, just like we could have with regular arrays, with one-dimensional arrays. The syntax is slightly different now. Instead of one bracket, you're going to need two. That denotes a two-dimensional matrix. I usually call it MAT for matrix. One thing we can do is we can immediately put the values in, just like we did in the other one. So what do you want to think of a two-dimensional array? We think of a matrix, so something like this. But how AP is storing it, it's an array of arrays. So at position 0 of this array, we have an entire array. At position 1 of that array, we have an entire array. So it's an array of arrays. Of course, we might not exactly know what we have right away, so you can always just say int mat is going to be a new integer array, and then give the length of each piece. Okay, so the first one always stands for the row. The second one always stands for the column. How I remember this is RC cola. Rows, then column. So here I just wanted us to know what it looks like. So this would be the first row. The next one is the second row. And then the third row. So rows go this way. Because you think about rowing your boat, it goes right and left. Right here are your columns, because columns hold up buildings. So this 2D array would be pictured in our mind like that. But how we kind of see it in the computer, it sees it as this big array, and there's several positions in this array. So this would be row 0, row 1, row 2, and each side inside of those we're going to have a whole nother array with values. So a two-dimensional array is an array of an array. Now I'm sure you can do an array of an array of an array, but I would imagine the notation gets a little bit easier, maybe not 3 brackets, but I really don't know. Never even looked it up. Maybe I will today. So we want to create a 2D array of Booleans with 5 rows, 3 columns. Remember, RC cola. So we want a two-dimensional array of Booleans. So we use the data type Booleans, except for you probably should spell it right. We know it's a two-dimensional array, so we need 2 square brackets. I like to call mine mat. It's going to be a new Boolean matrix. We wanted to have 5 rows and 3 columns. Create a 2D array of strings with 4 columns and 3 rows. So this time our data type is going to be string. Again, mat is going to be a new string. Be careful, they gave us in the wrong order. They told us the columns was 4 and the rows were 3. All right, so now reading them off. We can think of it as an array of arrays, but I think it's easier for most of us to think of it as a matrix. So I'm going to write this as a matrix. Remember, this first one is all of row 1. The next one's all of row 2, all of row 3. So remember, this is row 0, row 1, row 2. This would be column 0, column 1, column 2. Now, For AP, all of our matrices will be rectangular, which means every row is going to have the same amount of items. There's going to be no jagged ones. So if one row has 3 elements, they're all going to have 3 elements. We can have different size arrays inside the arrays, but AP does not cover that. So it wants the values at position. Remember, this is your row, this is your column. So 0, 1 is 4. 2, 1, so row 2, element 1. Remember, we always start at 0. It wants to know where 7 is, so 7's right here, so it's going to be row 2, column 0. We want to know where position 6 is. 6 is right here, so that's row 1, column 1. 10 is right here, so that's at 0, 0. And lastly, 3. Did I write that wrong? Is there 2 3s there? Oh, there should be 2. Okay, good, because I was kind of confused. So 3, so this would be row 1, column 2. Same thing, I'm going to write this out as, it's the same array, so I'm going to just leave it up there. So we're going to take values at 0, 1. So values at row 0, column 1 is 4. And we're going to add it to values at 2, 2, which is 2. So this value is 6. Values at 2, 1, so row 2, column 1 is 9. We're going to multiply that by 2, then divide it by val 0, 0, which is 10. So you're going to have 18 divided by 10, but that's an integer divided by an integer, so you do integer math, which is 1. Values at 1, 0, row 1, column 0, 13. Values at 2, 0, so the second row, the 0th column, and this one's going to be mod 3. Remember, modulus tells us the remainder, so 3 goes into 7 2 times with a remainder of 1, so 13 plus 1, which is equal to 14. And now we need to fill in this array. So I'm going to go ahead and write my rows, my columns. It tells me at row 2, column 3, we have 5. Row 1, column 3, we have 3. At row 0, 2, we're going to take what's at 1, 3, which at 1, 3 was 3, multiply it by 2, so it's going to be 6. So 0, 2 would be 6. We're going to take what's at 0, 2, which we just found out was 6, and we're going to mod it with 4, which is 2, so it's going to go in 0, 0. At 2, 0 is going to become 15. Then we're going to take a 2, 0, which was 15, and we're going to add it to the one at the 0, 0's position, so that's going to be 17, and you're going to go at 2, 2. So then we're going to have 20 divided by first row, third column, which is 3. Remember, we do integer division, so it goes in there 6 times. So in A, 1, 1, we're going to have 6. Row 0, column 1 is 12. It's going to take the 12, and it's going to multiply by what's at row 2, column 3, which is 5. So 60, and that's going to go into row 3, column 0. And then you're going to take, which is 0, 2, which was 6, and you're going to add 3, so that's 9, and it's going to go at row 3, column 2. Now, we have several missing spots, but remember, it's still started as default. Default for integers is 0. Default for doubles, 0.0. Default for Boolean is false, and default for objects is null. So if we want to determine the number of rows in the array, so let's think of what it looks like. So I'm going to write out how the computer thinks about it. It has one matrix, and inside that matrix we have little matrices, not matrices, but arrays. So you have a big array with little arrays inside them. So if I want to find the number of rows, that's asking for how many elements in my big array. So that's just going to be mat.length. If I want to know how many columns there are, I have to pick up one element of the row of the matrix, the first element or any element of the big array, and figure out how many things are inside it. So I'm going to grab our matrix at position 0 and then find the length of that. Now, in general, you're going to say the matrix at column R and then find the length. But since AP is always going to be rectangular, we can always default to row 0. Write a static method called check squares that accepts a two-dimensional array of doubles and returns true if it's a square and false if it's otherwise. Well, it's going to be a square if it has the same number of rows and columns. So, public, they told us static. We're returning a Boolean. We're going to do the method check square. We're going to pass in a two-dimensional array of doubles. So all I need to do is check if the rows are equal to the columns. So return mat.length if that's equal to the array at position 0. So this right here is checking how many columns we have. This one's checking how many rows we have. Now, we could have created an if statement, we could have defined a Boolean and checked that. There was lots of ways we could have done this, but it really is just one line of code because what's inside that parenthesis is returning true or false. This is checking for equality. This is a Boolean operation. It's either true or false.